Welcome to day 39 of our standard template library course. Today marks a significant milestone as we move from the theory to hands-on application. It's time to pull together everything we have learned about STL containers, algorithms, and functional tools in a real-world context. For today's project, you will be building a full-fledged application using C++. You will be choosing one of the following projects to work on: a task manager, a calendar scheduler, or a cache system. This is where you get to be creative, solve real world problems, and showcase your skills. Let's dive into the three project options. First, we have the task manager. This is a great choice if you want to create an application that manages tasks and their priorities. You will be adding, sorting, and updating tasks in a well organized system. Next, we have the calendar scheduler. In this project, you will create an application to help users organize events, ensuring that there are no scheduling conflicts and allowing users to view their calendar in different formats, be it daily, weekly, or monthly. Lastly, the cache system project will challenge you to create an optimized storage system. The goal here is to implement a least recently used LRU or most recently used MRU cache system, perfect for fast data retrieval in applications with limited memory. The choice is yours. Each project will allow you to apply your STL knowledge in unique and interesting ways. Choose the one that excites you the most and let's get started. Before you start coding, let's remind ourselves of the key STL tools that will help us in building our project. The containers are at the core of your project, allowing you to store and manipulate your data. For example, you might use vector for ordered collections, dequeue for efficient insertions and deletions at both ends, or map for key value pairs. You will also use algorithms to manipulate the data in your container. For example, you can use sort to organize tasks, find to locate an event, or remove to delete items efficiently. Another powerful feature of STL is the ability to use functional tools such as lambda functions and custom predicates. This let you write cleaner and more flexible code. Don't forget about utility types like pair for two elements and tuple for more than two. You will see how each of these tools plays a vital role as you implement your project. Let's focus on the task manager now. In this project, you will be creating an application to manage tasks based on their priority, deadline, and status. The basic features include the ability to add tasks with specific attributes like name, deadline, and priority. You will also be able to update or delete tasks as necessary. Sorting is a key feature. Your task manager should allow users to sort tasks either by priority or by deadline. You should also implement functionality to filter tasks based on their status, like completed or pending, and allow users to search for tasks or by keywords. This will involve searching algorithms and sorting algorithms and will help you understand how to manage large datasets efficiently. Next up is the calendar scheduler project. This application will help users organize events in an efficient way. Key features include the ability to add events with details such as the event's title, date, time, and location. You can then implement the ability to search events by specific date ranges. One of the most important features of this project is to detect event conflicts. If two events are scheduled for the same time, the system should notify the user. You will also need to sort events by their date so users can see them in chronological order. Finally, the ability to view events in different formats, daily, weekly, or monthly, will add a lot of versatility to your calendar. Finally, we have the LRU cache project. This is particularly useful for optimizing performance in systems that require fast access to frequently used data. The core feature is that you will store key value pairs, allowing you to retrieve data in constant time, which is the gold standard for cache system. When the cache reaches its size limit, it should evict the least recently used item to make room for new data. The LRU technique ensures that frequently accessed data remains in the cache while rarely used data is removed. You can also configure the cache size and optionally visualize cache hits and misses. This project will help you understand how dequeues and unordered maps can be used together for high performance data access. Here's a suggestion for your STL structures to use in each project. For the task manager, you can use a vector of tuples to hold task information. Each tuple would store details like the task name, deadline, and priority. This structure allows you to easily sort tasks and retrieve them based on specific attributes. For the calendar scheduler, a map works perfectly, where the keys are dates and the values are vectors of events scheduled for those dates. This ensures quick access to events on any given day. For the cache system, I recommend using a DQ to manage the order of elements combined with an unordered map to store key value pairs. This combination ensures fast access to cache data while maintaining the correct order for eviction. Before jumping into the code, take some time to carefully design your project. Start by defining the key classes such as task, event, and cache item, and identify the key attributes and methods for each class. This design phase is critical because it will help us structure our code and avoid unnecessary complications later. Think about how your STL containers will interact with each other and which algorithms you will use. For example, how will you handle sorting tasks? How will you search for events? A solid design ensures that your code remains clean, modular, and easy to maintain. Here are the criteria we will use to evaluate your project. First and foremost, we will be looking for correct STL container usage. Make sure you select the appropriate containers for each task, whether it's a map, a vector, or a TQ. Your use of STL algorithms should be efficient and well implemented. We also care about the modularity of your design. The code should be organized into classes and methods that are easy to read and maintain. We will be looking for how efficiently you solve the problem, especially if you can handle large amounts of data quickly. Bonus points if you add a user interface or even a command line interface CLI to interact with your application. Now that you are ready, it's time to build your project. Start by picking the project that excites you most and sketch out your design. Begin implementing your solution using C++ 17 or 20, and remember to keep your code modular and well cemented. Once you are happy with your work, consider pushing it to GitHub to share your progress. This project is not only a great way to demonstrate your understanding of STL, but also an excellent addition to your portfolio. Good luck and enjoy the process of creating something amazing. You have got this.